Hey guys, so today I wanted to talk about strong acids and strong bases. And so the 7 or 8 strong acids that your professors and teachers will want you to know are hydrochloric acid, hydrobromic acid, hydroiodidic acid, then we have sulfuric acid, this is perchloric acid, nitric acid, and phosphoric acid, and just chloric acid. So depending on the selection by your professors on which ones you have to memorize, these are typically the ones you'll have to memorize for your test. And so the reason why these are such strong acids is because when you put them in water or a solution, they generate a lot of hydronium ions. And we know that a hydronium ion is a water molecule with an extra proton on it. And this water molecule, let's just start off with the water molecule by itself, has 2 lone pairs of electrons, right? This is what makes it polar. It has that tetrahedral geometry, but since it has 2 lone pairs, there's an unequal distribution of, it's not planar, I guess. It's not going to be, the polarity is going to be going in different directions. Okay, so our water molecule is going to want to take our protons off of all of these compounds. And it's going to do that by let's just say we're dealing with HCl, right? The lone pair of electrons is actually just going to attack your hydrogen, and this bond between the hydrogen and the chlorine is going to go to the chlorine. So we're going to be left with HOH, and a lone pair of electrons, having an overall charge of positive. And since it's taking it, it's going to be left with a chlorine by itself with a negative charge. Okay? So that's really what makes it a base. The generation of a gigantic amount of hydronium ions right here, the H3O+, is what makes something an acid. Okay. Now, contrary-wise, let's look at bases. And the strong bases your professors will want you to memorize are bases that are in the alkali earth or alkali metal groups. So we're talking about, in the periodic table, the ones on the far left in the first 2 columns. Group 1, so we'll do 1 and 2. These are your alkali metals and your alkali earth metals. Now, being an alkali metal, something like sodium or potassium, they will be bases when they're combined with hydroxides. And a hydroxide is what causes something to be a base. If there's a generation of a bunch of hydroxides, we know that it's basic. Okay? So sodium hydroxide, potassium hydroxide, we know that these metals in these individual compounds are in group 1. And since the charge of metals in group 1 is +1, right? They like to ionize. In order for this to form an interaction, a bond, the overall charge of hydroxide must be -1. And so thus, sodium is going to be +1. So it's going to interact and form a bond. And then if we look at group 2, we're looking at something like calcium. So calcium is bivalent, right? It has a 2+ charge. Thus, there's going to be 2 hydroxides, right? There's going to be a subscript of 2, and if each hydroxide is a -1 charge, and we have 2 of them, we have an overall charge of -2 for the hydroxides. -2, and then a +2 for calcium. That's why calcium is bivalent with hydroxides. That's why it has 2 hydroxide compounds in order to balance the charges between them. Okay, and so all of your group 1 and group 2 elements with hydroxides in the right quantity are your strong bases. Okay, so that is strong bases and strong acids in a nutshell. If you have any questions or anything you want me to sort of answer, please email me at gforbes@poets.whittier.edu, or you can leave a comment on this video. Either or, take your pick.